Hello, dear all. My presentation is about remote sensing and GIS applications for unsustainable development monitoring in several cities, including Afghanistan, Kazakhstan, and Pakistan. So we have a big group of researchers, and this group of researchers from Kazakh British Technical University and Institute of Seismology from Kazakhstan. We choose several cities, including Kabul city in Afghanistan, and next Pakistan, Islamabad in Pakistan, and next city is Almaty in Kazakhstan. All these cities are similar generally because they're located in the valley area. So you may see my arrow. It shows this diagram, these schemes, and Kabul is located in this type of area, Almaty also, in Islamabad also. So all these cities are surrounded by big mountains, and they're located in the valley area. And all these cities have a big problems with many issues. So the main issue is related to pollution. So when you visit the cities, you may see big pollution. So this is this photo from Almaty, for example. You may see that we have a big pollution in Almaty area. So same situation in Islamabad and in Kabul. Another big problem, we have condensed building construction in all these cities, a lot of buildings. So you may see a lot of buildings, and all of them are very condensed, and cities are expanding, and they're trying to get more land from the mountains area. So that's why they destruct a lot of lands, and a lot of landslides happened. And all these areas are very unstable. So you can imagine that a lot of buildings are expanding, and these buildings are moving toward mountains, and so it's very unstable situation. Another big problem that with increase of population, people to get more water. People need more water, and how to get this water? So usually from the surface water, and most of the surface water already depleted, and people started to extract a lot of underground water. And when this extraction increase, when we get a lot of underground water, it may happen subsidence. So this building could be very unstable, and subsidence may happen, and it's quite dangerous. And another big problem what we have in all the cities are located in an earthquake area. So if earthquake happened, and if it combined with this problem of subsidence, so it will be very big problem. So you may see what might happen. So soil are very unstable. And so simply saying that if we don't have water here, so it will be very unstable area. And the problem of all this valley areas that, as I mentioned, all these cities are extract a lot of water. And so that's simply saying here we have a lot of empty areas. And so it's very unstable, and this subsidence happened. If this earthquake happened with this subsidence activities, it could be some domino chain of effect, and it will create a big problem. That is why it's very important to research and study this type of a problem. And it will be rational just to keep balance. If we extract water, we have to recharge it back. So to use something like managed aquifer recharge, so it's another big problem. And this unsustainable development of the cities is not so good. And for this purpose, to monitor this subsidence, remote sensing and GIS could be used. And Sentinel-1 with synthetic aperture radar were used to investigate Kabul city area. What's the situation with in Kabul with subsidence, and for this For this investigation, ascending and descending orbits were applied, and so it's combined with investigation of water resources, of surface water, precipitation, and underground water resources. And 4 subsidence balls were investigated, and where we have high intensive subsidence, and it's about more than 5 centimeters per year. We have subsidence in Kabul area. So 5 centimeters, more than 5 centimeters per year, land subsides in Kabul city. And so you may see on this map, so this is area of the Kabul area. So we have rivers, and we have this aquifers, and with intensive underground water extraction, this area is going down. So you may see in the red, it's this areas is going to subside, and you may see on this graph how all this, so in the red color you may see these folds, and this is a subsidence of this area. So it's getting very complicated in this area. And the highest subsidence on the upper Kabul basin, so it's the north part of Kabul and lower part of Kabul. So you may see this level, how it's going down in this area. So this is a cross section A, and this is it's another cross section of this area. So you may see this subsidence here. And when we check this level of groundwater decline, so in average groundwater decline were more than 16 meters. You may see during this last 10-20 years, people extracted a lot of groundwater, and the groundwater level is declining very much. And so it's simply saying we will have less water, and water level is declining. And so there is more extraction than recharge. So less water is coming to recharge this underground water aquifers, and a lot of water is extracting. So it's quite complicated situation. And for this purpose, we need to continue to investigate, and for another cities in Almaty, in Islamabad, we are going to set up something similar research, and we need to use more remote sensing and GIS research tools, and for this purpose we need more technicians. And University of Zagreb is quite strong in this remote sensing and GIS activities, so we would love to develop cooperation with University of Zagreb, with Faculty of Geodesy, and hopefully we may set up the certification training program, and with GIS, remote sensing, and Geodesy. And University of Zagreb has this lifelong educational program, and has certified geodesic technician training program. So it will be great to be connected and expand this cooperation. So hopefully with our Kazakh British Technical University and Institute of Seismology, we can set up cooperation and develop this certification training program. And it will be good to have a practical training program, and it would be very helpful to have intensive training program. So it could be something like 3 month and exchange program 6 month, or 12-month exchange training program, and it will be dedicated to learn some tools. For example, this company Leica and GeoWild with Hexagon Leica, they have a very good cooperation program, and it will be very helpful to set up this professional training program and to learn some tools, how we can apply different type of sensors and use geodesy equipment and track this subsidence. Leica has a lot of good technologies, and including this global navigation satellite system technologies with high resolution in the centimeter level tracking system. So it will be very, very helpful to learn all these tools. And also to develop web GIS tools also. So we need technicians who can upload all this information on the website and make all this information available for people. And people may track and see what's going on, and maybe to have some kind of system which will inform people in advance and with some prediction analysis. If we see some subsidence, we may predict, so this area is quite dangerous, and be ready if a combination of earthquake happened, and if we see changes in water recharge with difference in water recharge and underground and water subtraction. So it will be very helpful to combine all this information in one unified geoportal. So you may check these links. This is a link from lifelong education from faculty of Geodesy, University of Zagreb. You may see what kind of lifelong educational programs they have. And this is example from a Geographic Information System Application Technician Training Program. So it's a less than 1 year training program. So it will be great to set up this type of cooperation. And these are our contact, my WhatsApp and my email address. So please be in contact. I would love to be in communication and develop some cooperation with University of Zagreb. Thank you very much. Cheers.